Good evening, this is N7GES, and welcome to the NCARC Tech Net. Meet each Monday evening to discuss issues involving amateur radio. We respect each other's opinions and each other's personal ideas. We don't debate personal opinions and that sort of thing, and keep the topic in mind here as we discuss things. Everybody has ideas. Everybody has various degrees of knowledge, and this is a place to come and ask questions and get answers. Part of Elmering goes back to very, very early days of radio when people had an Elmer, a person that they worked with that taught them and showed to them the way radio works and helped them to learn. Helped them to begin learning on their own as well, but always was there to give them advice and help them learn some of the things that were important and may have been hard to learn on their own. So, that's the premise of the net. We always start by taking check-ins just to see who's around. So at this point, who would like to check in?
KC0SUN, Alec in Fort Collins.
This is K1DEG, Plantville, Mike.
Good evening, Kevin. This is Kilo Delta Zero Tango Yankee Uniform Joe in Loveland.
This is November 8, Juliet, Alpha Yankee, J in Loveland.
N6GN in Fort Collins. AE0BQ, Alpha Echo 0 Bravo Quebec, Daryl in Longmont.
Good evening, Kevin in the net. This is Whiskey 0 Delta Delta Zulu Dave in Greeley.
This is Alpha Echo 0, Charlie Foxtrot, Ben, Fort Collins.
Kilo Charlie 0, Romeo Bravo Tango, Jim, Fort Collins.
Kilo Alpha 6, Echo Tango Echo, Jim in Loveland.
KB0SCX, George in Berthoud.
Well, let's back through who I have here, and what a list. KB0SCX, KA6, ETE, KC0RBT, AE0CF, W0DDZ, AE0BQ, N6GN, N8GAY, JAY, excuse me. I knew that didn't look right. KD0TYU, K1DEG, and KC0SUN. Welcome to all of you. Others, please.
Good evening, Kevin. This is Kilo 0 Delta Bravo Echo, Debbie in Fort Collins.
Kilo
Okay, welcome Debbie, K0DEB. There was another call right after that. All I caught was a kilo. Try again.
0 Echo Victor, Eric, near car.
Okay, very good. Hey, I haven't heard you for a long, long time. I hope everything's going okay. Very good. Thank you, folks. Anybody else?
N0EMP, Greg, Fort Collins.
Right, welcome, Greg. N0EMP. Wow, quite a list tonight. All right, we probably will just go ahead and get started then. Others who wish to check in later may do so, certainly. If you have a comment or question, just give me the suffix of your call, and I will recognize you and go ahead and make sure the air is clear for you that way. We won't have, hopefully, so many doubles. I would ask that you would be careful not to jump in too quickly, just because we have a lot of people out here. Also, as I said, do remember to give your suffix first and wait to make sure that you've been acknowledged and we don't have a double. This is N7GES. Our topic tonight was 3D printing. I have had a lot of interest expressed in this topic. I do hope that we'll have several people who can give input on this. I know that we have at least one, and I do hope that we'll have more than one that can give us insights. I would like to keep the topic oriented toward amateur radio. I know there are people very interested in other things that are sort of on the controversial side. I'd like to stay away from those issues only because this is an amateur radio net, and I'd like to keep it to that. And I think there's probably plenty of stuff going on in that area that we can chat about. So, does anybody, first of all, have comments they'd like to make? And then I will open it up to questions. I know that KC0SUN has lots for us. Is anybody else on here that is using a 3D printer at this time and would like to share anything about it? And then I will send it back to Alec. ETE, good, go ahead.
Yeah, I've been using 3D printing for a couple years now, making a lot of parts and mounts and a lot of stuff for amateur radio. Just figured I'd get on the net tonight and kind of listen to what other people are doing and possibly help answer some questions if anything comes up that I'm knowledgeable about.
Okay, very good. Anybody else? Okay. We will have to share back and forth between at least the two folks here that we have that have been using 3D printers, and perhaps we'll get a few more as we go along here. KC0SUN, if you would like to share a short bit of stuff here, then we can make room for some questions and answers and discussion there.
This is KC0SUN. So what I'm going to start with, I guess, is the quick question and to get the ball rolling of, what is 3D printing, first of all. For those that maybe aren't entirely aware of exactly how it works, they're aware of its existence, but not necessarily how it works. And what it is this. First of all, there are many, many forms of 3D printing. You can 3D print many, many types of materials. Those materials all have different processes and ways for them to work. I believe what most of this conversation we're going to be having is about is not 3D printing Draco engines for a Falcon 9 rocket, but more 3D printing plastic parts. So the way it works is pretty simple in concept. It melts plastic as it pushes it out of a nozzle and lays it down in layers. And as the layers cool, it lays the next layer on top of that and the next layer on top of that, so on and so forth. It comes out of the nozzle in a similar way that cake frosting would come out of a frosting bag, only it is a lot tinier. You can get very fine and accurate detail. There are multiple different types of plastic materials to print with. They all have their own properties. But in the end of the day, the entire reason for it is that you are able to do so many things that you couldn't do before right in your house, like prototype and design parts, test different things, make replacement parts, make anything you think of. You can think of it, then design it into the computer, and then 3D print it, given you have a 3D printer that is capable of doing whatever material and whatever size it is that you want to print. So I've got experience with it, and ETE, and thank goodness I'm not the only one here. I just figure open this up at this point to questions and see where we go from there.
Okay, very good. Thank you for the synopsis, and that was good and very complete. Thank you. ETE, any additional comments you'd like to add to that before we start opening it up to questions and that sort of thing?
Not really. That was a pretty good example and overview of what 3D printing is and what most of us use it for, as far as home use and that. I mean, you can use the same programs if you have the same CAD program for doing machine work and everything else. And so it's a lot more familiar to people that are machinists and that than they realize it is. I mean, it's just the opposite. Instead of using a lathe to take material away, you're building material up to make the part you want.
And if I could just interject,
go ahead.
A very important point, which is that there's more than one piece of 3D printing. There are two totally different worlds that meld together, one of them being software or the design phase, and the other one being the actual creation phase when the print is made. The design phase overlaps with a lot of other design phases. So, as you said, if you're familiar with drafting and design, engineering, mechanical design, all of those, even lathe working and woodworking that is computer aided, uses a lot of the similar softwares and the same, in a lot of cases, code to do the work.
So, Fox Zero, Colorado boy, checking in. I'm sorry I'm late.
Hi there, Mike. Glad you checked in, and you're certainly welcome anytime. So thank you for being there. Thank you. Thanks. Very good. Anybody at this point have questions about 3D printing? How it works? What you do? How you get started with it? Any of those questions that you might have for some of these folks? BYU. BYU, go.
Yeah, a question for either one of those people. I'm used to working with Unigraphics, all these other 3D type modeling type softwares when I was working Kodak as an engineer. Question for that, does any one of these softwares design actually work? In other words, what I'm used to doing is I'm used to building something and then we're putting it on a CNC and work. Is that somewhat similar to how the 3D printer works? Go ahead.
SUN?
SUN, go.
The answer is yes, yes, 1,000 times yes, because what you're doing with a 3D printer is identical to what you're doing with a CNC machine. The only difference being that one is adding material, the other is removing. However, those CNC machines quite often, not all, but most, at this point, use what's called G-code, which is nothing more than an instruction set telling the machine what to do. And when you're 3D printing, it uses the same code. The 3D printers are the children of those CNC machines. The softwares work similarly. As a matter of fact, some of the exact same softwares that you're used to and the same file types that you're used to seeing work with 3D printing. So those would be like the 3DF and STL and DXF file types that you're used to working with 3D modeling are the same file types that you use with 3D printing because the modeling part is identical. And then the G-code files that you're using for instructions to the device to tell it to do what it's supposed to do are also almost identical. So it is the two, if you're familiar with one, getting into the other is a snap.
Okay. Further questions on that, Joe?
You said it's compatible. Of course, I'm used to dealing with, like you say, a CNC machine which is going to remove material. But is Unigraphics or even the AutoCAD 3D modeler, which I've used maybe 2 or 3 times total, is that importable into these 3D printers, or does it have to be converted into something different?
The model software, for the most part, AutoCAD especially uses DXF files. There are other 3D object files, OBJ files. These are all have nothing to do with the what you're going to do with them. They're specifically related to the software. Those model files, those that actually store the three-dimensional information, are the same, identical in 3D printing as they are in CNC. So if you have a piece of software that you're familiar with using and it can save or export to a model file that is an industry standard kind of model file that would be used for CNC machining, DXF is the one that comes to mind. That DXF file could then be imported into many other softwares and also allow you to turn it into a file that would then be printable, which brings up a specific subject, which is what the slicer is. We'll get to that in a minute, but to answer your question first, yes, they are compatible, and most of those softwares work quite well together across both industries with no problem.
Okay. Any other comments from anybody? ETE or anybody else that has just joined us? GN, go.
I'm wondering if you can simulate it is fundamentally a build-up process. Can you simulate a removal process? Specifically, what I'm wondering is, could you make coupled cavities? Suppose you built up the airspace of a cavity, metallized the outside, and then remove the plastic with a solvent or something. Is there any method for generating a void that you can design the dimensions, 3D dimensions of? I'm thinking of coupled cavities at microwave.
SUN?
SUN?
Yes. As a matter of fact, you would do it with some of the same softwares. There are some smart slicers that do things like that. There's also materials specifically designed for what you're talking about, which gets us into the material conversation. There are three big materials that most people use for 3D printing are polylactic acid, PLA, ABS, which we're all pretty familiar with because most of our plastics on our radio are made out of it. And the other one is PET, I think. And I don't know exactly the words. If I've got the acronym wrong, I'm sorry. But it dissolves in water. You can 3D print with it, and then you can take the 3D print that's printed with two different materials, one of them being your polylactic acid, or PLA, and the other one printed at PET, and they print at the same time with a dual extruder. And when you're done, you have your voids built up with the material that dissolves in water, and you have your solids built up with the other material. You would then dissolve them, you would stick it in water, come back in an hour, and all of the PET would be dissolved. You could then metallize it, and you would have those voids. There's probably some other ways to do it, I'm sure. That's just an example of one way to do it. So there are solutions for those types of situations. The other thing is that you can print, because you print one layer at a time, you can print solids and voids at the same time, so you may not even need to use a dissolving product as long as you were able to print each layer. Think about taking whatever the object is and slicing it. If each layer is printable, then the whole thing is printable.
That makes sense. Thanks.
Additional comments on that from anyone else that's been printing already 3D? All right, this is N7GES, and this is the TechNet. Let's go on. SUN, I believe you've got some other information, such as slicers and things like that. So let's go on through the techniques a bit more, and then eventually I really do want to talk about how do we use this in amateur radio? What sorts of parts are people building? What sorts of patterns are out there for use and that sort of thing? But if you want to talk about a bit more about the process here, let's go ahead and do that next, and then we'll move on to the other.
Okay, I'm going to be switching back and forth between radios so the one doesn't overheat. So here is the process. The process of making a 3D model in the computer is, there's many, many ways to do it. There are lots of software out there, and they all end up with pretty much the same thing, although the file formats are different. You have a model of an object that you can spin around and look at from every angle. So it's three-dimensional, virtually in your, on your computer screen. When you then want to take that model and turn it into a 3D printed object, you cannot print the whole model at once the way you would with an injection mold. With an injection mold, you have a negative space, and then you inject it with the plastic, and the plastic fills up the entire space at once, and you end up with an object that perfectly replicates the negative space of the mold. With 3D printing, you have to do it one layer at a time. And those layers can be different thicknesses depending on your printer's capabilities. They can be incredibly thin, down to 50 nanometers. So there's all kinds of different opportunities there, but you have to slice the model. You have to turn that 3D object into a stack of slices. Each slice is going to print as one layer as the head of the printer moves up or the table of the printer moves down, depending on the style of printer you have. You're going to print one layer in X and Y, looking straight down. X is up and down, and Y is left and right. And then the print head is going to move up just a little bit and print another layer on top of that. And that's what a slicer does. It creates that the code, which is called G-code, same thing that's used in CNC machining. It creates the code that tells the printer what to do for each layer. Once you have that information, you can then send it to the printer, and the printer will start printing layer 1, then it'll do layer 2, all the way up to thousands of layers later when you have an object that pretty much looks exactly like what you had in the computer. One major difference is that at this point with consumer model printers, at least with solid printers, you can see the layers, or even if you can't see them, you can rub the back of your fingernail across them and kind of feel them. So that's just a little bit about the process. There's a whole other style of 3D printing, which I don't think we should get into, but which uses light and resin to 3D print an object, and the resolution on those printers is a lot higher. Those printers are a lot more expensive, and it's a completely different process. If we want to cover that, we can probably do that in a completely separate thing. The only thing different at the end of the day is the way it prints. Everything else applies equally to both types of printers.
Okay, very good. Questions, please. Any questions, please?
A1DEG.
Go ahead, Mike.
Do they have a process of printing like silicone, as in a silicone sleeve for an HT or a mic or anything like that?
Well, the answer is yes and no. You can 3D print any material that you can mold, but it depends on how much that printer is going to cost. So silicone is the material itself, when it's in its moldable form, is suspended in acetic acid most of the time, like basically vinegar, and then as it cures, everything changes and it becomes silicone. Now you could 3D print that material if you had a particular 3D printer designed specifically to 3D print silicone. Home 3D printers don't normally, and not that I know of, but I don't know everything, but don't really print in that material. However, there are similar materials, flexible materials, not silicone flexible, they're not as rubbery as silicone, but there are incredibly flexible materials that you can 3D print with that are available for home printing. The printers that print those materials do tend to be in the kind of the second tier of price ranges, not the lowest entry level, but yes, you can print that kind of material, just not silicone specifically.
Right, this is N7GES. This is the Tech Net, the NCARC Tech Net. Okay, very good. We've had a lot of information here. Let's get into parts. Mike asked about HT holders. Let's talk about parts that have been already made, parts that we have plans for, because you have to remember that with these printers, you use models and plans, and there are a lot of those already out on the internet and various places, so you don't necessarily, you may not have to design your own, but you may be able to run something that somebody else has created. So let's talk a little bit about that. What sort of radio related things are out there, and what sort of radio-related stuff have you done? ETE, I know you've done some already, but let me send it to SUN first, and then if you would like to expound on a little bit on what you've been making with yours, I think this would be a good time for that. So, Alec, first, go ahead.
Well, the question's not what you can make, it's what can't you make. And the only thing you can't make is something that's too big for your printer. If you follow the Facebook page, you'll see that I've been kind of prototyping a different type of battery holder for a Baofeng radio. I got the initial design in a place called Thingiverse. Thingiverse is a website. It's the YouTube of 3D printing. If you're looking for a video, you go to YouTube and search it there, and you can probably find it. If you're looking for a thing, a 3D model, they do other things as well, but that's their bread and butter. You can get it from Thingiverse, and all those models are normally free. The nice thing about 3D printing is that there is a huge, massive community out there of people to help, people that are constantly making models, people that are editing models, and you as Kevin said, you don't need to know anything about 3D modeling to start 3D printing. But once you start 3D printing, you will probably learn a lot about 3D modeling as well. The two, because they do go hand in hand. You can edit pieces and parts. There are all kinds of mounts and holders and things for all different styles of radios. There are universal mounts for vehicles, all kinds of just any little piece of plastic that you say, I wish I just had a little something to go right there. That thing either exists or can be made.
SCX?
SCX, go ahead.
The obvious question is, for home-style 3D printers, what's the cost? What's the size of objects that you can build?
Well, those things, two things normally can go hand in hand. The cost can be as low to get in and actually have a 3D printer that is usable to print all kinds of things. The cost is as low as $200 to actually have a unit sitting on your desk that works, and it goes up from there. The costs can be lower if you want to build things yourself, but to start out, that's probably not the best idea. The build area, or the build plate area, which is what you're talking about of what size, in the price ranges of under $500. There are build areas as large as 400 by 400 millimeters cubed. It's all different sizes. The only thing that makes a difference as far as the way it prints, because they all use stepper motors. So you just need longer bars and a larger plate to build a bigger printer. So they've made them all kinds of large sizes. As long as the software in the printer is aware of the size of the build plate, you can make them very large. So people have the larger ones, like I said, tend to be closer to the $500 and up range. There are a few maybe under $500 that can do that larger 300 millimeter area. But for small pieces and parts, you can get into, say, a 110 millimeter circle that's 120 millimeters high for just about $200.
Okay, thank you, George, for the question. Good one. Let me see. Jim, KA0ETE, can you give us some examples, perhaps, of things that you've been working on and things you've perhaps already put into operation?
K6ET. And one of the big things I've been doing a lot of lately is building wire dipole antennas. I built a couple Go Box radios that have mobile radios mounted in with their own internal battery and solar panel, and trying to find a way to be able to carry multiple different frequency antennas with me. So I decided to build some wire dipoles. Build all of the insulators, or print all the insulators, centerpieces, everything for them. Also do a lot of cradles for HTs. Inside my Jeep, I do a lot of four-wheeling. I got sick of the fat stock mounts that they have for the remote face plates for the AC radios that they were never seemed to be at the right angle, so I printed all of my own custom mounts to where I could adjust the angle to where I like it, where it's easily visible, but this way. Printed replacement belt clips for HTs, and it's like SUN was saying it's endless you can print. I mean, I've printed replacement knobs for my radios also.
We had just a little bit of interference there. What was the very last thing that you said you built for your radios?
I've had to print replacement knobs for the volume control and frequency knob. Well, a lot of people have had radios where they start to get older and loose and fall off, and eventually they get lost if it's a mobile radio. And as long as you have a micrometer and stuff to where you can measure the stud that comes out for it and where the slot is located or the flat spot, print your replacement knobs, and instead of ordering one online or taking a trip down to HRO.
Jan?
Hold on just a minute, GN. Just wondering, how practical is that as far as amount of work and expense and that sort of thing? Versus just ordering a replacement knob.
For someone that's never done it, it's probably not practical. I mean, if you know your way around the CAD programs, I can print a new knob in less than an hour. That's including design time and everything, which an hour doing that's a lot less than ordering one or driving somewhere to get it. Belt clips and stuff like that for the HTs, less than 2 hours between design and printing.
SUN.
Just a second. Okay, interesting. And let me send it to GN, and then we'll come back here.
Thanks. N6GN, Glenn in Fort Collins. I'm wondering about material strength for dipole insulator supports. How many pounds of tension can you? I mean, if you hang a wire on each end of it, say, what kind of tension? What kind of tension can you support?
I haven't done any true strength test to see where the breaking point is or anything. But I've done a 20-meter wire dipole, and it had no issues holding up 30 feet of RG8X coax in the air. The wires on the end, I would say I've probably put at least 50 pounds of force on them. A lot of it comes down to when you're printing it, as was mentioned earlier with the slicer and that, you also set the infill density. A lot of printers, their default setting for the infill is 10%. It leaves void, it saves on material and that. A lot of the stuff that I print whenever I'm doing something like that I know is going to be under stress, I will increase the infill, usually up to 40-45%, which makes it a lot stronger. It uses more material, but it's a trade-off between strength and cost.
All right, SUN, you had some more comments. Go ahead.
Well, just two comments about actually two things. First one is you mentioned practicality. Getting into 3D printing, if you're getting into 3D printing for practical reasons, most of the time it's not right. I mean, I'm not saying that it can't be, but for the most part, unless you have a design in mind and you're like, well, I just want to 3D print these at home because it's cheaper than buying this particular part, sometimes that's the case, and there can be a practical side there. But 3D printing is a lot like ham radio. There are practical sides to it, but it is it's a thing to learn about. It's a hobby to, explore, which is why most people get into 3D printing. I believe anyway. The second thing was regarding the material strengths, and ETE hit the nail on the head. There's material strength depends on the way the item, the object is designed and then printed. If you print a solid cube, it's going to be a solid cube. That's going to have the material strength of whatever material you're using. There are the two main types that people use are polylactic acid, which is a plastic that's made from, actually it's made from corn, but it is a printable plastic, and it has pretty good material strength for most of what you need for like knobs and stuff. But if material strength becomes an issue and you want something that has a stronger impact resistance and a stronger tension resistance, you can print ABS, which is the same material that the plastic cases on most of your radios, when they're made out of, when they say, they're made out of strong impact resistant plastic, that is ABS. So you can print that material with a lot of the consumer model printals. It is a little bit more difficult to print. There's a little bit more tweaking you have to do to get it just right, but you can do that. And once you have that set up, you can print pieces and parts that are incredibly strong for the fact that they came out of your printer, in your house, that are basically the same strength as the type of piece or part you would get from a commercial design.
Okay, this is N7GES, and this is the Tech Net. Very good. Interesting stuff here. And obviously your strength would also have to do with how you built the product and if it has thin parts or if it's a thicker construction and that sort of thing too, I'm sure. So that's very interesting. Questions at this point, please? Any questions?
CF?
A CF, go.
Since being printed layer by layer, I was wondering what the water resistance was like and whether water could seep into any of the holes, and then if it's outdoors, the water freezes and causes it to shatter. Well, I use CF.
SUN?
SUN?
Well, the answer to your question is yes. Yes, it can be water resistant if you print it to be. It has to do with what you have your slicer set to. When you have a 3D object, if your 3D object in the computer doesn't have any holes in it, it's got solid faces, and you want it to be a solid water resistant thing, then when you print it out, you just need to make sure that you're using the right settings to make the walls solid. There are, when a 3D printer prints, it can print different types of patterns. It can print a grid, it can print spirals, it can print all these different types of patterns. Most often, when you're building up layers, you print a grid. The first layer goes down, and the layer is actually pretty solid with no holes in it because the lines touch each other. The next layer goes down in the opposite direction. So if you're going up the x-axis, the next one goes down on the y-axis. And those layers are touching each other. So to make something water resistant, you just need to make sure that the shell is thick enough so that you have built enough layers to block out any water. As far as water intrusion and for freezing and things like that, it's not really an issue because the size of the holes that would possibly be in, and it would only be in the very top layer of the surface. If there was maybe the very first layer that went down, there was maybe a small sliver in the grid, the next layer would cover that. So even if those existed because of some failure in the print setting, it would be so small that surface tension would not allow water intrusion. And like I said, it would just be touching the next layer anyway. If there's 4 or 5 layers that make up your wall, which is very thin actually, it would be pretty water resistant. Now the materials, specifically polylactic acid, which is the main material. Grab a nickel. Polylactic acid is biodegradable. So, and it will not biodegrade if it's just sitting in water. It is, like a lot of plastics, has more sensitivity to sun. If it's sit in the sun, UV is going to slowly over time break it down. However, if it is in an environment where it is maybe, touching the ground and it's getting rained and snowed on and stuff like that, over time, and I can't say how long the time that is, because it all depends on the microcosm in your backyard, it will eventually break down. It's designed to be biodegradable. It's supposed to be that particular material anyway is designed to be biodegradable. Printing with ABS, however, you end up with a part that, again, can be water impermeable and will not biodegrade and will last a very long time. And if you spray it down with a little bit of UV protectant, you can sit out in the sun for a very long time as well.
Okay.
So,
okay, we had a little bit of a double. CF, was that you?
yeah, sorry about that. Go ahead.
No, did you have additional question?
Oh, yeah. Yeah, I was a little bit concerned because earlier we said that you can feel the little lines across when you print something. When you scratch your fingernail across it, you can feel the little notches. It's not completely smooth. It seems like that any water that touches a surface freezes and then thaws, it will cause damage to it. At least that's what I'm thinking, but maybe not. I don't know. And I also had the other question about the strength issue too, compared to injection molded, but I guess I'm not sure if there was an answer to that either. Well, AE0CF, clear.
If water froze on the surface, those are I wouldn't say microscopic, but incredibly tiny lines. The same way water pops out of an ice dish, if it froze, it would pop out. It would not break the product at all. I actually, speaking of ice trays, I built an ice tray. I 3D printed an ice tray to make specific ice cubes. And I put water in it, I throw it in the freezer and freeze it, I pop it out, and I've never had a problem with anything like that, and I've used it many, 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 many times. As far as the strength of injection molded versus 3D printed, to be entirely honest, it's not a fair comparison. Both of them can be stronger. It comes down to engineering. However, if you 3D print a product that is identical in mass, meaning that the infills are the same, the design is the same, to an injection molded product of the same material, there is little, if none, negligible difference in strength in those two parts. And the winner could be either one, depending on the part, because obviously if you're engineering something that's supposed to be strong when 3D printed, it'll be stronger when 3D printed, and the injection mold will lose, and vice versa. But the difference is negligible. They actually use the same process, and they're using it with metal, not plastics, but they use the exact same process to 3D print rocket engines. And when they do tests of the 3D printed engines, and they do, and the molded engines or the engines, the strengths are comparable. And the same idea, although it's a totally different world, applies to the plastics. They are bonded together. When you lay those lines down, the top layer bonds to the layer below it. It melts it a little bit, and they are chemically, or they are melted together. They are a plastic welded bond, and that happens layer on layer on layer.
All right, thanks. A0CF TechNet.
You're welcome, and questions there. Lots of good questions. Any other questions, please?
KC0 RBT.
RBT, go ahead, Jim.
Yeah, I had a question. If you were to create a DWG or DXF file, 3D modeling file, are there any third parties locally or on the internet that you could have your parts generated? Instead of investing in a high-end 3D printer, could you generate the file and have someone print that for you, and is that an economical solution? KC0RBT.
SUN?
SUN, go ahead.
Absolutely. It is, if you have a need for a part, something you can't buy otherwise, which would normally be the case if you're planning on designing it yourself, and you want that part, but you want it printed, and you've got your AutoCAD file or whatever. There's a lot of good software out there to make those things, and you want that part 3D printed. There are many services online. As a matter of fact, Thingiverse has that service. You can go to thingiverse.com, open up a little account. You can actually upload your file, and then say, I want this printed. And they'll give you all kinds of different options, all kinds of different materials, different quality prints. All of those things will be in those options, and you can get very specific. As a matter of fact, even if you are a 3D printer, and you own a 3D printer, but you happen to need a particular part in a particular material or in a particular size that your 3D printer doesn't do, but you only need that one part. You're not going to go buy a whole new 3D printer just to print that one part. So you're in the middle of your build and realize you need a part that's bigger than your build plate, you can just order it. It is, as far as being economical, it's not incredibly expensive. It's nowhere near as expensive as oftentimes going and buying similar style parts that are specially made or having someone else design it or anything like that. There is a nominal fee, which is basically they're charging you for the cost of materials, the time to print it and shipping, and a little bit of profit. But it's not incredibly expensive. And if you go, like I said, to thingiverse.com, it's T-H-I-N-G, like the word thing, and then I-V-E-R-S-E, as in the end of universe, thingiverse.com. You'll see all of those possible ways that you can get things ordered and that have been printed out.
Well, thank you for the information. That answered my question totally. You know, I run Draft Site, and I was just curious if I was able to develop something that I needed, I could get it printed, and the answer is yes. So thank you. Back to net, KC0RBT.
ET.
TE, go ahead.
Yeah, just to expand on that last question a little bit, you can even go places, I'm not sure if any other libraries do. Loveland Library has 3D printers that patrons can use at the library. You can design your own part, take the file there. They have multiple 3D printers for use. It does cost. I know the cost is very minimal. Someone I know had something printed there a couple years ago right after they started it. They started doing it in 2016, but I think it was $7 or $8 to print a mount for a radio.
I did not know that existed. I actually may use their services. Thank you for telling me that. SUN.
And so I would assume at the library you turn in a file and somebody else will actually run that for you and bring you the part and charge you for whatever however they set up their fee schedule.
No, you can actually take the file in. If you're not familiar with the printer, they have someone there that'll help you go through and get you set up on the printer and show you how to do it to where you can. It's an actual learning experience for you as well, to where you get to actually print the part yourself.
If I can be heard over that noise, we got something or other going on here, so I apologize. That's going to create a problem. This is N7GES, and this is the TechNet. We've been covering a lot of information here about 3D printing. Any other questions?
GES, I just want to confirm that you were completely heard over the noise.
Okay, thank you very much. Any other questions, please?
KE0PNG.
Good evening. PNG, go ahead.
I was wondering if you could use something other than plastic, like perhaps a clay, and in case you wanted to do a ceramic thing. They cook up part in a ceramic to fire it up afterwards.
SUN?
SUN?
Anything that you can extrude, you can 3D print. However, I'm not aware of any hobbyist home use clay 3D printers. The way that something like that would work is you would have a hopper that was then squeezed, and you'd be extruding the clay while the head moves. That would require some the identical file types, the identical models, everything would be identical. The only thing that would be different, matter of fact, the methodology of printing it would actually be the same. The only thing that would be different would be the actual extruder and the print head or the print nozzle, like I said, it would have to have some sort of hopper, and it would have to have a way to feed the material. I'm not aware of that for a hobby home use. I would venture a guess, and I would probably say that I'm 80% sure that exists. I'm 80% sure that someone has done exactly that thing. I am just not personally aware of it. It is absolutely possible within the realm of 3D printing. There's no difference between doing that and 3D printing a plastic material other than those that I've already said.
Thank you. Kilo Echo Zero Papa November Round Golf. Back to Matt.
Okay, and thank you for joining us and asking the question. Other questions, please.
W0ASP with a question.
Good evening, Jerry. Go ahead.
Question is about conductive materials for 3D printers, and how conductive are they?
Yes, they exist, and they're basically metal that's been embedded into the plastic, so you can print. They do the same thing with wood materials, and I haven't used them, so I can't speak on their conductivity.
Okay, because I'm wondering if this would be useful to, say, make an antenna part or a cavity filter or even a conductive trace on a board.
There are specific materials designed for home use 3D printers that print the standard polylactic acid. PLA is what we call it, plastic. As I said, what they do is they actually have a very fine metal, copper, I think, that's in the filament. The filament comes on a big roll, and it looks like it's basically a big long piece of wire, but it's made of plastic. And then you print out with that. And I guess the thinking is, and as I said, I've not used them, and I don't have a lot of familiarity with them, but the thinking is that there's so much of that stuff in there, so from end to end, there's a connection. My assumption is that they work. I see people using them with success. So there is something that you can look into there. If I was you, I would look into if you do a Google search for conductive PLA, then that's Papa Lima Alpha. You should find some information about that and maybe some experiences from other people that have used it.
Thank you kindly. W0ASP back to net.
Okay. That could lead to some very interesting things. Insulated continuity bars. Wonder about what's out there. Wow. Very, very cool stuff. And then it comes down to how much time does one want a set take to make the design, and how fun is it to make your own stuff that fits exactly what you want? Wonderful. Any other questions, please? Okay, any final comments from our two main presenters, I guess I would say. SUN?
Well, if people have any questions, you can always ask me later. If you think of something later on, I'll be more than glad to assist in any way that I can, or if I can't, I might be able to help point you in a direction to somebody who can. I will say this about 3D printing. It is incredibly fun, and it's a lot like ham radio in the fact that there's always more things to do and learn. It is not something that you get into mostly for, oh, I need this part, so I'm going to buy a 3D printer to get that part. It's more of a learning hobby. It's a maker hobby. It's a lot like working with Arduinos and Raspberry Pis and ham radios in the sense that you're constantly learning new things and figuring out new ways to apply them. There is a whole world of stuff out there that's already been made that you can simply print out, and then you can learn how to do the designs, make your own things, print them out, edit designs, figure out new ways to do things, build all kinds of cases for your, maybe for your Arduino project or your other things, so it fits directly into the type of hobby where you're doing and building and making things, which is why it goes hand in hand with ham radio and that entire side of things. So if you're interested in getting into it and you need some advice or don't know exactly what to buy, there's a lot of help out there. I'd be glad, again, to answer questions. I'm sure ETE would also be glad to answer those types of questions. There is multiple levels that you can get into, as I said, from $200 on up to thousands. And they all have different things that they do, and they have different communities around them. I would stress that it is very good and important to make sure that when you do decide to buy something, before you buy it, you go online and start looking at the community around that particular device to make sure that if something goes wrong, and it will, that you'll be able to get the help you need, or all of the settings are out there and all of those things are available to you. Other than that, I would suggest that everybody just go buy a 3D printer because they're great.
GN?
GN, go.
Comment and a general question for the net. Comment is, it looks like conductive PLA is 30 ohm centimeters for a 1 centimeter, 30 ohms for a 1 centimeter cube. It's not a low impedance kind of thing, but it might, you have to think about it in your circuit design, but it might be usable. And the question is unrelated to 3D printing when we come to that.
Okay, so say that again, 30 ohms per centimeter?
No, a 1 centimeter cube across faces is 30 ohms. So, I think the spec says if you lay down 10 centimeters of it, you get 2 or 3 k ohms if it's 70 mils wide, and if it's 100 mils wide, it's a k ohm or something.
And that's for the conductive specifically PLA, correct?
That's what it says.
Oh, okay. Thank you. Appreciate that. Lots of room for further study and interesting enticements to check into it. Jim, ETE, any final comments here?
And it's pretty much the same as the other. I mean, it's 3D printing's a hobby, and something that if you're interested in, you can get into fairly inexpensive or spend as much as you want. I mean, it's same as a lot of other things. The quality stuff, if you want to print stuff that you could potentially sell or mass produce, those printers are going to cost you a lot. If it's something for occasional use, just as a hobby, it's inexpensive to get into. I find it to be a lot of fun and gratifying at the end whenever I build something and know that I made every part that's included in that. Whenever you can go out somewhere and with antennas, for example, and you can buy parts and different things online or go to the store and buy them, but whenever you can print it yourself, you can make it your own. It's like all the centerpieces for my wire dipoles have my call sign embedded in them, to where I know it's mine, I made it, and it's a little bit of pride knowing that what you can do and what you have the ability to do. I mean, it's same with amateur radio. Everyone goes for that long distance contact. It's same thing.
Well, you guys have got me sold. I won't be doing it for a while because there's a lot of visual aspects to it, but it just sounds like an awful lot of fun. And that's not to say there isn't perhaps a way for me to handle it. So I have no doubt of that. It's not going to happen right away, but if it could, you've got me sold. So that's cool. Any last questions? I think we're going to need to wrap this up shortly. So, and I think we've answered a lot of things. But any last questions?
ETE with the comment.
ETE, go ahead.
Yeah, I just wanted to, real quick, I meant to mention it a little bit ago. I mean, if someone's interested in knowing if they'd be able to do it, I mean, someone that's not familiar with CAD programs, there is a website, it's Fusion 360, that has commercial and industrial grade 3D modeling software that is free for hobbyists. And you can go on their website. I can't exactly remember what it is, but if you just Google the Fusion 360, you can download their CAD program, sign up as a hobbyist, and it's completely free of charge, and it'll at least try designing something, and it'll let you know how much learning you would have to do or if it comes natural to you.
Tinkercad. It's called Tinkercad.
W0ASP with a question.
ESP, go ahead.
Kevin, something you just said, how you're not going to mess around with this for a while, leads me to a particular question I have, which is the possibility of taking a data set, for example, a star map or a digital elevation map, and taking that data and then printing it into a 3D object that could be used by someone who's visually impaired to understand the information that they wouldn't otherwise get in an image.
SUN with an excellent answer to that one.
SUN?
Absolutely. As a matter of fact, for a buddy of mine, I just got a heart that was built from a data set and 3D printed it for him. They got a data set of information from inside of a human heart, since he's a cardiologist, and we printed that. Any information that is in 3D coordinates, is going to be some way to take that information and turn it into something. It's going to take work. It may take, a little bit of ingenuity. Stars are not connected by things, so you probably want to actually have like sticks or some other representation that could be followed. However it would work best for the person who's visually impaired. But yes, things like that are absolutely applicable to 3D printing, and if you're looking to get into that kind of thing, there are a bunch of other tools specifically that work with, and I'm sure Kevin knows a lot more about them than I do, but, for the visually impaired, that would probably go hand in hand with those processes. So if you have a star map, you have, and it's just a 3D data set, you can plot that out in some other piece of software, like actually a buddy of mine wrote a piece of software called Laser Boy, which was designed to build laser show files, but it does a lot of things like that as well. You can build points in three-dimensional space. You can then export that to a DXF file. You can then bring that DXF file into whatever CAD program you want to use and add whatever pieces and parts to it that you want to make it usable. But yeah, those kind of things there's a lot more to it. There's a lot more software and design involved. But if you've got the data set, if you work with it enough, you can get it to come out of the nozzle of the printer.
Okay, Huey, I have a lot of 3D data sets, for example, like antenna patterns and radio astronomy sky maps and stellar maps, too. I could imagine printing, say, a base level, and a star would be like a little a mountain or something that's off of that, and the brighter the star, the taller the mountain.
Exactly like a gravity map. Yeah, that would be absolutely something that's. I wouldn't even think that would be too complex. If you had enough patience and the right software, that shouldn't be too difficult to do.
So in terms of the right software, you're saying something like this Laser Boy, did I hear that correctly? Is that something that one could use to start a data set and to make 3D printer files?
Specifically, that piece of software, it was used to take a different data sets. They're in a different format than probably what you'd be using, and then map out the information into three-dimensional space and then export that into a DXF file, which you could then do more editing to. There's not to take a specific type of data set like that and turn it into a special type of map or a special type of print is going to require a custom piece of software or a custom process more than likely. maybe not just a single piece of software, but you're going to import that data into something and get it into a known industry standard format. Once it's in that format, you would then bring it into an editor that edits industry standard format files. There's dozens and dozens of them. Some of them are free and some of them cost $5,000. There's a lot of them that are free, though. And then you would make whatever edits you need to it to turn it into a model to be printed. The data set itself is just going to be points. It's just going to be points in space, so you can't, there would just be dots if you were going to try to 3D print that. If you were, the way that you're talking about it, you'd have to process that somehow. You could find a way to automate that process, but again, that would be very customized. And this is exactly the kind of thing that 3D printing leads to, because these type of questions, the answer is always going to be yes, you can do that if you can figure out how to do that. There's enough information there for it to be done. You just have to decide how you want to do it and what that process is going to be.
Okay, it sounds like my specific application would take quite a bit of research, and that's a pretty steep learning curve from someone who's never used a 3D printer. W0ASP, back to net.
I would add to that that's what the community is for. It's like, as I said before, the 3D printing community is very vast and rich and very helpful. And if you were to suppose that idea to a group, maybe on Reddit or some other 3D printing forum, I would guess that you would get a lot of very useful feedback, which would cut down the learning curve of the process considerably.
Okay. Excellent dialogue and ideas. And that is fascinating. Yes, there's been a lot of stuff over the years done to make something 3D that makes things more understandable by touch. Certainly, reproducing them in a harder format like 3D could certainly have its advantages over using a softer substance, which we've done before. Resolution always is a bit of a problem because too high a resolution sometimes causes things to be a little hard to decipher. But we could have a whole dialogue on that. This is N7GES, and this is the TechNet. We've had some really, really interesting discussion. I already called for final comments, and then we had more questions, and that's okay. Do we have any other questions at this point?
Deanne?
Deanne, go.
I'm wondering if anybody on the group has a means of reading a 3.5-inch floppy. I know it's a bit retro, but I have a couple of small files I'm trying to transfer to something else, and I don't have a single 3.5-inch floppy reader in the place. Anybody around have one?
W0ASP, I have one.
Ooh. Is there any chance that we can get together?
Sure. I live in Berthoud.
Well, I could certainly come down. I just need some contact information. Are you okay on QRZ.com mail?
Roger that. Yep. W0ASP on QRZ. You'll get my address, and I think that email works.
Okay, thanks, Terry. I'll drop you a note. N6GN. Thanks, Kevin.
N6GN. There's also the college up here. If you're in Fort Collins, I think that you are. I could be wrong, but the college up here has a store where they sell all their old stuff, and it's called the CSU Surplus Store, I think is what it's called. And they've got a ton of computers in there. You could probably buy an entire system or just a floppy drive for a very minimal amount of money. if you could plug one into your computer, they most likely would have an external 3.5-inch floppy drive you could just plug in and use. Just that as an alternative. That's the CSU surplus store.
Yeah, good idea, except I've been trying to get rid of all that old stuff. I've just been too successful. So if Terry has something, that would be great. Thanks a lot, Kevin.
Sure thing. I think I still have a functioning computer with a 3.5 drive in it too. I've been holding on to it for that very reason, but I'd have to check and see where on earth it is. But I do understand that. I've still got a bunch of 3.5s too, none of which I don't believe have any thing really important, except that I also have a couple of different musical instruments that use 3.5 floppies, and they still function. But at some point in time, that's going to end. So at some point, I need to take some time and copy data to another format so that it's still usable, which I know how to do. I just haven't done it. So yeah, I'm living on borrowed time, I know. All right, any other questions? And I will open it up to general radio or related questions here. Okay, looks like we have covered the gamut and covered the questions. Remember that our programs are streamed to YouTube, so you can review them that way. We are on Echolink, and I should have mentioned that at the beginning as a way of contacting, or as another way of checking into the net. That would be via W0UPS-R. We have our own YouTube channel, which we're streaming to, and which we're adding extra episodes. Your easiest way to contact us would be through NCARC mailing list, specifically Elmers, ELMERS, at NCARC.net. As I said, Elmers, the term Elmer was used in the beginning stages of radio to designate somebody that was teaching us about radio, somebody that was personally helping somebody else to learn. So that's where the term came from. If you have comments about the net, comments you'd like, questions you'd like expressed on the net, or questions about the net itself for us, please feel free to use that email address. That address is also available if you need help with a particular radio or a particular antenna style, a particular aspect of radio. Email those questions as well. So take advantage of that knowledge base, and we'll be happy to help you as much as we can. That will do it then for this evening. I thank my presenters, KC0SUN and KA6ETE, for providing their experiences and information. I appreciate all of you checking in and asking questions. It's made the whole net an interesting net. And I have again had a huge busy day and busy week. So next week's topic is still yet to be decided. Please look for it on the web page and announced on the maybe on the net here later in this week. I'll try to get that out shortly. I apologize that it's not ready for announcement today, but we'll get something figured out shortly and go from there. Again, thanks to all. I'm going to clear the repeater for normal use and say 73s to all. N7GES, thank you again, and the channel is clear.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.